All right, our next transformation today are turns. They are called rotations. And a rotation, specifically what we're going to talk about today, is the angle of rotation. So how far or how much it's going to turn. One of the first ones we're going to talk about is 90 degrees rotation. And a 90 degree is a quarter of a turn. And I'm going to take my point, whatever that point is. I'm going to switch the A and the B, and then the B gets a sign change as well. The next turn is 180 degrees. 180 is a half of a turn. And again, I'm going to take this time my point, any point that I want to start with, and I keep them in the same location, but they each get a sign change. And the last one we're going to talk about today, the angle of rotation, is 270 degrees. And 270 degrees is 3/4 of a turn. And this time I'll take my point, I'll switch the A and the B, and A also gets a sign change. The other piece we're going to take a look at today is specifically the postulate. The postulate 4.3 talks about rotation, and it talks about rotation being a rigid motion. And rigid means it's going to keep its size and shape. So just like our slide, our translation, we had a shape and we slide. That's a translation. It didn't change the shape or the object. It kept the same size. It kept the angle. If I did the flip, remember the reflection, I still have a rigid motion because I'm keeping the same shape and the size of it. I'm not increasing or decreasing the size. And the same with the rotation. I'm going to take the shape and I'm going to turn it or spin it. And again, it's called a rigid motion because it keeps its size and shape. And the last thing today that we're going to talk about is rotational symmetry. And rotational symmetry means I can take an object and I can turn it, and in less than 180 degrees still have symmetry. So for instance, this first one is asking about this parallelogram. My drawing is not very good, but it wants to know if it has rotational symmetry, meaning can I turn this thing and turn it less than 180 degrees, so before less than a half of a turn, or exactly a half of a turn, can I get this to match what it looks like right now? And the answer is yes. The same here with my hexagon. Can I turn this before I get to that half turn, or exactly the half turn, and still have symmetry? Can I still make it look like this? The answer is yes. And this guy right here, the answer is no, because in this trapezoid, if I turn him, even if I turn him a half of a turn, which would be like this, these are not the same. They don't have symmetry. So only rotational symmetry if I can turn that shape and either before, on a half of a turn or less, I can get back to this same shape. That's rotational symmetry.